So the last forecasting method we're going to look at is exponential smoothing. Exponential smoothing is kind of a weighted forecast, a weighted moving forecast. We're going to use an alpha to determine how much weight we want to apply to the previous time period's forecasting error. And that's kind of the difference with this one. In this one, we won't be looking back 2, 3, 4 time periods. We're only going to be using the one right above it. However, you'll notice that kind of whatever happened the time period before is going to have an influence on the next time period, and so on and so on. So it says exponential smoothing is a weighted average of all the observations in a time series, because one forecast and observations then affects the one below it, and so on and so forth. So you'll see the same formula. They use it in a couple of different methods. This is the exponential smoothing formula that they typically use, but they will show you another way that you can use it as well. How you read this right here is, go ahead, let me turn my pen on. So for the next time period, remember anytime we see t minus 1, the forecast from the next time period is going to be the actual for this time period times whatever alpha is assigned, plus 1 minus the alpha times the forecast from the time period above. So the larger the alpha, the more emphasis you're giving to what actually happened in the time period above. The smaller the alpha, the more emphasis that you'll be giving to the forecast from the time period above. This is also one of those things where you may run exponential smoothing using 2, 3, or 4 different alphas to see which one gives you the most accurate forecast. So if you've determined that exponential smoothing is the best forecasting method for your business, for your data, you may still need to run it with a few different alphas to determine, well, which is the best alpha that gives me the most accuracy in my forecast. Typically, your alpha is going to range anywhere from 0 to 1, and we know this. This is everything we've learned so far in statistics. So this is the formula that you'll want to make sure you're familiar with when working with exponential smoothing. Now, the book also shows it to you in a little bit of a different way. You know how we've taken formulas before, and instead of z, we solved it for x or solved it for n or something like that. This is kind of the same thing. They mathematically readjusted the formula. This could be another way that brings you to the exact same conclusion or exact same calculation as the initial formula. Most of the times they work it, if you watch them work a problem in the book, they're going to use this formula to work it. So this will be the method that I use as we proceed in this example. So we are still using the same 12 weeks of gasoline sales that we have from the very beginning of this chapter. And what they want us to do is they want us to compare using an alpha of 0.02 and using an alpha of 0.03 and see which is better, which one gives us the more accurate forecast. When we're doing exponential smoothing, we're not going to do all the different mean square, percentage, and all that. When we do exponential smoothing, all we're going to solve for is MSE. So it saves us a little bit calculations there. Okay. So how do you start an exponential smoothing formula? Remember, it said to calculate the forecast for the next time period, you need to take alpha times the actual for the current time period plus 1 minus alpha. Sorry about that. 1 minus alpha times the forecast for the current time period. Starting an exponential smoothing problem is a little different than starting other problems. Because you don't have a forecast or because you don't have a time period prior than the first time period, you can't work this equation for the first time period. So typically how you would start an exponential smoothing is you take your actual and you carry that over and also make that your forecast. Because this is not a real forecast, however, you're not going to have a forecasting error. When you work this through, if I were to do this formula right here, if I were to take the alpha, so alpha is 0.2, times the actual, which was 17, plus 1 minus the alpha, so that would be 0.8, times the forecast, which again is our initial forecast. When you calculate that through, it also gives you 17. So technically, when you're starting an exponential smoothing formula, your actual for the first time period becomes your forecast for the first two time periods. That's just kind of mathematically how it works out. Now, we did work it out with the equation, so this was a real forecast, so now we can get a real forecasting error. So 21 minus 17 gives me a real forecasting error of 4. All right, I'm going to change pen color, and we're going to work through the next one as well. Okay, so how would we get this forecast right here? To get this forecast right here, we're going to use the data from the time period above it. Okay, so I'm going to kind of follow the same format. So for the forecast for time period 3, I'm using the data from the time period above it, time period 2, alpha of 0.2 times the actual was 21, plus 1 minus my alpha, 0.8, times the forecast of 17. I'm going to go ahead and calculate that through. Again, they're continuing to use 2 decimals, so I'll go ahead and make sure I leave that as a 2 decimal, and that comes out to 17.80. What would the error be? My actual for this time period minus my forecast for this time period. So 19 minus 17.8, that gives me a forecasting error of 1.2. Okay, let's do one more and then I'll give you a chance to work through the rest yourself. So let's do the forecast for time period 4. So to forecast time period 4, I'm going to be using the data from time period 3. So the forecast for time period 4 is once again the alpha assigned times the actual, which was 19, plus 1 minus the alpha times the forecast of 17.8. Doing the math, that gives me a forecast of 18.04. Taking my actual for period 4, subtracting my forecast, gives me an error of 4.96. Alright, so what I'd like you to do, go ahead and pause the video, complete the forecast for this example, and then I said we're going to be using MSE. So also go ahead, once you have your forecasting error, go ahead and do the MSE. So square that forecasting error and sum that up for me. Okay, so let's go see. You can compare your numbers. I left the first few kind of reminding us how we got the formulas. Remember, your first one is not a real forecast, and therefore you will not have a forecasting error with that. So go ahead and compare your numbers. The remaining through 12 is on my next slide. And then let's go ahead and calculate our MSE. Our MSE would be our sum of the squared forecasting errors divided by what? Divided by the number of actual forecasts that we could do. So let's go see how many that was. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that would be divided by 11. So go ahead and calculate your MSE. Okay, so what did your MSE come out to? It should have come out to 8.98. So what does that mean? Again, it really means nothing. This is kind of an arbitrary, meaningless number until we run other forecasts that we can compare this again. So just make note, our alpha for using an alpha of 0.2 gave us an MSE of 8.98. And remember what they wanted us to do. They wanted us to compare this to using an alpha of 0.03. So, I'm sorry, 0.3. So once again, I want you now to go back and run this data, run this forecast, this exponential smoothing forecast, using an alpha of 0.3. And then we'll look over the numbers, compare them, and come to our final conclusion. So go ahead and pause the video again to give yourself time to rework this problem using an alpha of 0.3. Okay, so if you've worked this now using an alpha of 0.3, again, the same fundamentals applied. For the first week, we only had actual. If you would have carried that actual over and also made it your forecast, running through the formula, it would have given you the same value as a forecast for week 2. Remember, since this was not an actual, since this right here was not an actual forecast, we're not going to have any type of forecasting error that goes with it. How we got this forecast right here, and I have it in the bubble above it, but to get this forecast right here, to get week 3's forecast, we had to use week 2's information. So the forecast for week 3, this time we're using an alpha of 0.3. We're using week 2's information. The actual amount sold was 21,000 gallons, plus 1 minus alpha. The forecast was, the forecast was 17. And that gave us this forecast right here of 18.2. Sorry about that. When we get our forecasting error, that gives us a forecasting error of 0.08. One more time, just to make sure everyone is on the same page. We do one more. How do we get this forecast right here? The forecast for week 4, week 4's forecast. Week 4's forecast, we're using week 3's data. So our alpha assigned times the actual for week 3 plus 1 minus the alpha times the forecast for week 3. And that gives us this value right there. Don't forget, we are always going to take our forecasting error. And for exponential smoothing, we're only going to worry about calculating MSE. So to calculate the MSE, we need to square that forecasting error for each of our time periods. So once you've done that the whole way through week 12, and again, go ahead and pause the video if you need to and compare your numbers to make sure you were correct. Let's go ahead and calculate the MSE for an alpha of 0.3. So we're going to take the sum of our squared forecasting errors, and we're going to divide that by the same thing that we did before. How many actual forecasts did we have? Let me go pick another color where it might be a little easier to see. How many actual forecasts did we have? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All of those were actual forecasts. So divided by 11. And if you calculate that through, that gives you an MSE for an alpha of 3 of 9.35. So let's compare the two. An alpha of 0.2 gave us a mean square error of 8.98. An alpha of 0.3 gave us a mean square error of 9.35. So which is our better forecast? You always go with the lowest error. The lowest error means the most accuracy in the forecast.